implicitly. So this is the circuit. So initially spring is released and it is connected to this operation is say D. Then what I do is separation will become D minus X1 and the spring will get elongated. So here I have to show electrostatic force and this side spring force. So there is a wire you show it. So now the switch is closed. So this is you call KX1. Any symbol you can take it. So let me, the second situation now. The capacitor charged, the plate B starts moving and comes to rest in an equilibrium position with 10% of displacement. So that this Fe is equal to, so directly we can go for now. So what is Fe? Fe1, I'll write it. In this case it is. So Fe1 equal to Kx1. So this should be equal to Q1 square by 2A epsilon naught. What is Q1 charge on this plate? Q1 minus Q1. So Q1, what is the capacitance of this capacitor now? Let it be C1. So C1 equal to F naught A D minus X1. So therefore Q1 equal to C1 into E. This is what E has given E only. Oh, fine. So this value of Q1 I'll substitute there. So this will be epsilon naught A E D minus X1 whole square 2A epsilon naught Kx1. Okay, this is the situation. So now instead of this, what is telling, it suddenly charges. I think he has brought one situation. He should have given next week at least. Yes, sudden charge. So he's making some time constant of circuit little bit in the same year. So now the separation what happened will become equal to, let it be D2 or, okay, we can do one thing, D minus. It will become D2. Some separation itself between the plates will become D2 where the spring will get elongated. Charge, let it be Q2 plus Q2 minus Q2. So this is happens suddenly, it charges here. Here what happens, it comes to equilibrium gradually. It's telling it comes suddenly. That one. In that case, the separation between the plates, let it be equal to D2. Okay, that D2, what will be the decrease in the plate separation if charge is done in a very short time? That the plate B could not shift noticeably again. Last, he has put one more sentence. Let the separation between the plates, let it be D2 now. So this will be equal to Q2 square. Now first we'll define capacitance C2. C2 should be equal to epsilon naught A by D2. I think only, yeah, fine. Let's go for this one. This will be Q2 should be equal to C2 into E or epsilon naught A D2 into E. So the new force will be Fe2 will balance the spring force. So this Fe2 should be equal to K2. So what is Fe2 should be equal to Q2 square by 2A epsilon naught. So what is that Q2? Q2 should be equal to this much epsilon naught we do have these two and some relationship could be in position. I don't know what this sentence is. What will the decrease in plate separation? The charge is done in very short time. I just assumed it's situation like this here. Now, what is the sentence I'm missing? So I could not understand further. This much I have. So if I want, I can eliminate f naught a e square dividing these two, this one. So I'll get x1, x2, and d2, that one. So what is d2? d2 should be equal to d minus x2. And I think some relation between, for x1 he has given one equation in terms of d. Substituting that, we'll get the x2.
Sir, the remaining sentence is the separation between the plates decreases by 10%, sir.
To rest in an equilibrium position.
Full stop. After that, the separation between the plates decreases by 10%.
The separation between plates.
D. Between the plates, D decreases by 10%.
Okay, no, I think I can. Okay, now this x1 shall I write 0.1d. Okay, this one. So x1 should be 0.1d. Decreases by 10% means 0.1d. So x1 value we know it. x1 equal to 0.1d. So this is a condition. So substituting here. Now, what will be the decrease in the plate surface? The charging is done in a very short time that the plate could not shift noticeably. Then in that case also, the spring will get elongated. So here x2 will come. x1 I got in terms of d, no? So here the value of x1 I'll get it. d2 and x2, two are unknown things, no?
Only x2 is unknown, sir. We can write d2 as d minus x2.
But it's telling that d2 will be, it should be that we have to write only d2, no? Okay, this will be only d, it will come. d2 will be approximately, the further, d2 is approximately, as d2 I'll write it condition here. d2 equal to d minus x2, as d will be greater than x2. So d2 equal to will come. So here, solving this equation, call equation say 1 and 2, we'll get the x2. Actually, this after RC circuit, what happened, he could have asked it here because it depends upon the resistance of the circuit. RC circuits, we don't have idea. It will charge quickly or it will charge gradually. Based on that, this condition is there. You have to solve for x2 here. So we know x1. So from these two dividing 1 and 2, I think some equation will get it. Dividing 1 and 2 will get one equation. This condition is very important, what he has given. Applying this, so we'll get the x2, then we can compare it. Check answer whether it's coming or not. because like I could not
Sir, why
get
is
it.
D2 is equal to D, sir?
He himself is said, no? B could not shift noticeably. Okay. So I can write D2 equal to D. Then I can solve it.
Sir, X2 will be 0.729D.
It will be 0.729D.
729D.
So 73, or it will become 73%. Check, I think you have to check the value. No, check calculation once. Check calculation once.
What is the answer, sir?
Key not given.
Sir, in key it is given fourth option, sir, but in solution it is given second option only.
This equation what you gave, if we solve, we are getting second option only.
Second option. Okay,
Yes,
then you
sir.
make it. Just follow this equation. I don't know what is key, that one. This is a basic idea. Okay, so after 28, 29.
Sir, what difference does it make if we are charging it slowly or we are charging it instantaneously?
You are not permitting the at that instant when charge gets deposited and this elongation because of this value here, no, d minus x2 d. I think the value of x2 will come into picture. He has defined a condition like this. If it charges gradually, so it will come to equilibrium. If it doesn't charges, no, there the plate what happens suddenly gets charges. So suddenly a force will act here, and the plate will undergo displacement. Now at equilibrium, the plate will not be at rest, will have velocity practically. The second situation. In the third situation, it moves gradually, and at equilibrium will come to rest. The first case, the plate will shift gradually from rest to rest. In the second case, what happens? It moves suddenly, that one. So at equilibrium, it will have velocity. That's what happens here. You have to just go back to SHM, that's all. The plate will have velocity here now, here. When you are writing this equation, here what happens? The plate will be at rest. I'll write the equation. Plate B will be at rest. You have to apply the basics, nothing big, no application, no concept here. So here, no, plate B will have velocity. Okay, now everyone is asking 29 again. A metal sphere of radius is mounted on its side and is connected with an altimeter of negligible. I'll bring this. Okay, no, a metal sphere of radius, no diagram, of negligible capacitance. The meter reads 15 kilowatt. Another uncharged metal sphere. Two spheres connected by wire. Take help of the concept. Two spheres. Question number 29. Question number 29. It's like this.